So for today's lesson, we're going to be learning about electrons, Bohr models, and ions. So some of the learning objectives that we're going to hopefully reach today are describing properties of electrons, explaining how electrons are formed to create cations and anions, and drawing Bohr models for neutral atoms and ions. So we've previously learned a little bit about the basic structure of the atom and in particular the subatomic particles that are located in the nucleus, also known as protons and neutrons. This lesson is going to focus mainly on the electron. So some properties of the electron include that it is a negatively charged particle. So each electron has a charge of about -1. The electrons reside outside of the nucleus in what we call the electron cloud, something that we're going to be exploring a little bit later in depth in some future units. And then electrons do not contribute mass to the atom. So while protons and neutrons contributed about 1 atomic mass unit each, electrons are so small, and relative to those other subatomic particles, they don't really contribute anything to the mass of the atom. So just looking, it's about 2,000 times smaller than a proton, and that's why we just don't include it in any mass numbers of isotopes, nor the average atomic mass of an element. All right, so take a second and see if you can find out what is the difference between these atomic models. So really the only difference that you should see is that the one on the left is missing one of those blue dots. So it just going off of what you've already learned, you probably figured that these P with a positive charge is going to be a proton, the N with a 0 next to it is going to be a neutron, and that these blue dots that are outside of that nucleus where the protons and neutrons are located, those are going to represent our electrons. So you can see that the one on the left, the model on the left, is missing an electron compared to the model on the right. So if you were quick enough to count them, you would have noticed that on the left there are 17 electrons and on the right there are 18 electrons. So think about how that compares to the protons that are in both of these atoms. Okay, so that atom that was on the left had 17 electrons, which was equal to the amount of protons that was located in the nucleus. So when the amount of electrons is equal to the amount of protons, we call that a neutral atom. And if you think about it, all of your electrons are going to have a -1 charge. The protons are going to have a +1 charge. So it's really like they're canceling each other out, and overall that atom will have no charge. On the other hand, an ion is a charged atom. So when the amount of electrons differs from the amount of protons, overall, you're going to have either a positive or a negative charge. Now remember that with this example, we had 18 electrons. And since each electron has a negative charge and each proton had a positive charge, overall, this whole atom has a charge of -1. So electrons are pretty important when it comes to chemistry and chemical reactions because they can transfer to and from other atoms. So let's take this chlorine, this neutral atom that we had from the previous couple slides. Right now, this chlorine atom has 17 electrons. However, if my chlorine atom gains another electron, so I'll put a little arrow where that's gaining, it now would have that 18 electrons. When atoms gain electrons, they're actually becoming more negative. And these negative ions are also called anions. So if I'm referring to something as an anion, it means that it has a negative charge or that it gained electrons. Now you learned how to write isotopes in symbolic notation, and we can do the same thing for ions. So we're going to write the chemical symbol first. Remember that your mass number is going to go in the upper left. So remember, to get mass number, you're going to add up the protons plus the neutrons. So in this case, 17 plus 17 is going to be 34. All right, we're going to put the atomic number, which is the same as the number of protons, in the lower left. So I'll put my 17 here. And as I said, if we're gaining that 1 electron, now we have 18 electrons compared to those 17 protons. So overall, this atom, remember, had a -1 charge, and I am going to note that on my symbolic notation. So I also mentioned that atoms can lose electrons. When they lose electrons, they're going to become more positively charged because basically they are getting rid of negative. So if I look at this sodium atom, and if I lose an electron, basically it is going to another atom, I lose the electron. So now my sodium atom, which had 11 electrons because it was neutral, is now going to have 10 electrons. So if I put my 10 electrons here, all right, and I compare that to my 11 protons, overall, this atom will now have a +1 charge because I have one more positive than I do negatives. Now, these positive ions are also called cations. And one way that you can remember this is that cations, so think about the cat, like the animal, are positive. So cats have paws, get it? All right, I know it's cheesy, but it honestly helps remember. Another thing is that we can write the symbolic notation for a cation. So as we did before, we're going to have the symbol. So I'll put my symbol for sodium, which is Na. I'm going to find my mass number by adding up my protons and neutrons. So in this case, it would be 23. My number of protons was always going to be 11 for sodium. And then, as we said, we have an overall +1 charge, so we're going to note that on our symbolic notation. All right, so the models that we've seen today are actually called Bohr models. So if you can recall from learning about the history of the atomic model, Bohr worked off of Rutherford's idea that the atom is mostly empty space and that it has this dense positive charge in the middle. So Bohr also believed that these electrons are actually orbiting around the nucleus. But was this the most current atomic model? Okay, so if you were thinking like, no, this is not the most current atomic model, you are correct. So Bohr models were introduced or proposed in the early 1900s, and they are not the most current atomic models that we have today, but they're still used because they are a really simplistic approach to the atomic theory. And there are some accuracies that are present in the Bohr models. There's relationships between atomic size, electrons, and energy that still ring true from the evidence that we know. However, there are limitations to models because we don't know everything, and evidence is always being collected, and models and theories can change. So the limitations with the Bohr model, it doesn't explain that dual nature of an electron. So remember that electrons can be waves and they can also act as particles. It also violates the Heisenberg principle, and it does not work for larger atoms. So for this class, we're going to really do Bohr models only for about the first 20 elements on the periodic table. But if I just saw a Bohr model, what information can we identify using it? All right, I'll give you a second to kind of think about that. So looking at that Bohr model, what could you get out of that you know about atoms already? Okay, so some of the things that you might have typed in or wrote down about what you can identify using a Bohr model, the number of protons and the atomic number can be found here. Remember that protons is always going to be equal to the atomic number. And if I have a periodic table, I can use that information to find which element I'm basically dealing with. I can also find the number of neutrons. So if I have protons and neutrons, which are given to me here in the nucleus, I can use that information, so both of these, to figure out the mass number of the isotope. Because remember that mass number is equal to the number of protons plus the number of neutrons. Another thing that I can figure out from a Bohr model is the number of electrons. So with the number of electrons, I can figure out, is it a neutral atom or is it an ion by comparing it to the number of protons. And then last but not least, I can also note these energy levels. So these rings on your Bohr models, right, represent energy levels. And we will talk more about energy levels in future units once again. But one thing is that you should note that the one that's closest to the nucleus, that would be energy level 1, 2, and then they actually can go out to 7. So one of our targets was drawing a Bohr model or a Bohr diagram. You can see these a couple different ways online. I'm going to tell you how we're going to do it in this class and what's expected of you for drawing a Bohr model. So the first thing you have to do is determine the amount of protons, neutrons, and electrons. So you will be given some sort of information, whether it be in a chart, whether it be a symbolic notation. You'll be given some information and you might have to determine the other subatomic particles. The next thing you're going to do is put the number of protons and neutrons in the nucleus. So protons are usually denoted with the symbol P with a positive charge or sign, and then neutrons are going to be a lowercase n with a little 0 next to it because it does have no charge. And then you're going to place the electrons on the energy levels, starting with the one closest to the nucleus, which is also known as the first energy level. The energy levels, just a couple rules to follow. They have to be completely filled before moving to the next energy level. The maximum amount of electrons is going to differ depending on which energy level you are filling up. So the general rule to determine that is going to be 2n squared. And this n is going to represent the energy level. So I did a little bit of math to kind of show you how that works. So for the first energy level, if I take 2 and multiply that by 1 squared, it would just be 2. So that first energy level can only hold 2 electrons. The second one, if I do 2 times 2 squared, it would be 8 electrons. So that means that the second energy level, or the second ring, right, is going to only be able to hold 8 electrons. The third would be able to hold 18. And then, as I said, this actually can go on to about 7 energy levels. So you may have to be able to calculate how many electrons can fit on a particular energy level by using the equation 2n squared. And then you can also show these electrons as pairs. So we're going to be drawing our Bohr models looking a little bit more like this. However, if you're looking for extra resources or extra help, you might see a Bohr model drawn like this. Or sometimes they don't even put the number of protons and neutrons on the inside and they just put the element symbol. So you might see it a bunch of different ways, but our expectation is that you are putting those protons and neutrons in the nucleus, and then you are going to be pairing up your electrons, and I'm going to show you basically how to do that in the next slide. Okay, so our first example, it looks like we're given this symbolic notation. And it said that this is a neutral atom. Now, the way that I know it's a neutral atom is that I don't see any charges here. So since there's nothing right here, that tells me that this is not going to be a charged atom. It is going to be neutral. So the first thing that I see here is that we have a mass number given to us in the symbolic notation, and we also have our atomic number, which is also the number of protons. So right away, I know that the number of protons is going to be 14, and I know that I can calculate the number of neutrons by taking that mass number and subtracting the number of protons. All right, so I can put the number of neutrons and protons in my nucleus right away. And I would have 14 protons. And then if you do the math, 28 minus 14 is 14, so 14 neutrons. All right, so now I just have to place my electrons. So since we know that this is a neutral atom, and we talked about what a neutral atom means, if I know that I have 14 positive charges in my nucleus, that means that to be neutral, I would have to have 14 negative charges in my electron cloud. So I know that I'm going to have 14 electrons that I'm putting around on my energy levels. So for the first energy level, there are 2 electrons that can fit in that one. And I'm going to pair those up right away. So we're expecting you to kind of pair these up right away. So here are my 2 electrons on my first energy level. So I used 2 of these 14, right? So now I have 12 electrons left to keep going. My second energy level could only hold 8 electrons. So I'm going to show you how you put them on here. So before pairing them up, for these, I'm going to do 1 over here, 2, 3, 4, and then I'm going to pair them up 5, 6, 7, 8. All right, so right now I used up 10 electrons total, which means that I just used up 8 more. So I have 4 electrons left to put on my final energy level. So I filled up my first energy level, I filled up my second energy level. I'm going to fill up my third energy level until I run out of electrons. So as I said, we started with 14 electrons. We already put 10 on our model, so we have 4 more left. And before pairing them up, I'm going to actually put them on separate sides of my atom. And if this seems a little wonky, don't worry about it, but this is how we're expecting you to do it. So you're going to pair them up in that first energy level. You're going to pair them up in the second energy level if it's completely filled, and then you have to go one at a time until you run out of electrons. So as you can see, this has 14 electrons, it has 14 protons, and it's showing that it also has 14 neutrons. This would be an example of a silicon neutral atom. All right, so the last example we're going to do is an ion Bohr model. So I know that this is an ion based off of this symbolic notation because I see that +2 charge in the upper right-hand corner. All right, so it's a +2 charge, which means it's a positive ion. And if you remember positive, it's going to be what we call a cation. All right, so this cation became positive because we lost 2 electrons. And they didn't just float away into nowhere. Those 2 electrons were actually given to another atom, remember. So we lost 2 electrons. And that means that overall with this ion, I should be short 2 electrons, which means that I should have an abundance of 2 protons. So if I have 12 protons, given that my atomic number is 12, and my overall ion needs a charge of +2, that means that I'm just going to subtract those 2 to get my 10 electrons that ion actually has. So when I'm drawing out my Bohr model, remember that you're going to put the protons, which I have 12 of, in the nucleus, and then I'm going to put my neutrons in the nucleus as well. And to figure out the neutrons, you're going to take your mass number, subtract your atomic number. So I know that I have 10 neutrons here. All right, there is my nucleus. All right, my first energy level, remember, can only hold 2 electrons. So I will put those 2 electrons here. So right now I have 8 electrons left that I need to put on my Bohr model because I used up 2 of my 10. And I know that that second energy level can hold all 8 of them. So I'm just going to pair them up right away as I put them on here. So here's 2, 4, 6, 8. So overall, this ion is going to have a charge of +2 that we talked about. You can see that I have my 10 electrons placed on here, but I have those 12 protons in the center. So to show that this is going to be a +2 charge, I'm going to put it in brackets and then put a little +2 up here. If you have any questions, make sure you're asking your teachers. You guys will practice this on your worksheet today, and let us know if you need any help.